Hey everyone, let's solve Leetcode 2130, the maximum twin sum of a linked list. In a linked list size of n where n is even, the i's node, which is zero indexed of the linked list, is known as the twin of the n minus 1 minus i's node if 0 is less than or equal to I is less than or equal to n over 2 minus 1, right? For example, if node is the number of nodes is going to be 4, then the zeros node is going to be the twin of node 3, right? Node 1 is, and also node 1 is the twin of node 2. These are the only nodes with twins for n is equal to 4. The twin sum is defined as the sum of the nodes and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list, right? So let's take the first example. So as you can see, we have this linked list, right? So the blue ones are twins, right? This node and this node, right? 5 and 1 are twins, so their sum is going to be 6. And the red ones are twins, and their sum is going to be 6. So the maximum is going to be 6, right? So let's take the next example. And the next example, we have 3 areas is linked list, right? So the blue ones are just twins, right? And their sum is going to be 7, right? And the next twins are the red ones, right? These red ones are twins and their sum is going to be 4. And the maximum is going to be 7, right? Our answer is going to be 7. So how do we solve this problem, right? So to solve this problem, what we need to know is we need to know, we can just know the middle of the mid of this linked list, right? So to know the middle of this linked list, what we can do is, I mean, we need to know half of the portion of the linked list, right? This half of the linked list, right? So once we know this half of the linked list, or we can use, for example, a stack, right? For example, we can store the values from here. For example, we can store for example, we can store half of the first half of the linked list in a stack, right? Let's say I'm having 4 here. I'm gonna have 2 here, right? I'm gonna have 2 in my stack, right? Then wait, I'm gonna start iterating in the second half, right? Then what I'm going to do is the top of the stack value, as you can see, 2 is the twin of in this node, right? The node I'm just traversing, right? So it's going to be the twin of the top of the stack. So as you can see, 2 and 2 are just twins, right? Then I'm gonna sum these two. I'm gonna pop it from my stack first. Then I'm gonna sum 2, the one I popped from I popped it from the stack, and the one I'm just traversing, right? So their sum is going to be 4, right? There I'm gonna maximize my twin sum. Then whenever I'm at this position, I'm gonna pop this node from my stack, right? It's going to be popped from my stack, right? Then it's the one which I'm going to pop this is going to be 4, and the one I'm traversing is going to be 3, right? Then their sum is going to be 7, right? And the maximum sum twin sum is going to be 7. But this one costs us of n space complexity, right? So what if but we don't want use we don't want use a space, right? But instead we want to solve it using of one space complexity, right? So to solve it without using a space, what we are going to do is we can just first know which part of half the middle of the linked list, right? Let's say we have a slow pointer and we have a fast pointer. The fast pointer moves 2 steps at a time, right? So whenever the fast pointer is at the end of the linked list, the middle pointer, the slow pointer is going to be at the middle, right? Because the slow pointer moves half of the distance, right, of the fast pointer. So for example, for s, if s is going to be they were initially pointing the head, right? Then we will move, let's say we will move the slow here, and the fast is going to be at this position, right? And whenever the the slow is at this position, the fast is going to be yeah, the fast was here initially. The fast is whenever the slow is at this position, the fast is going to be out of the it's going to point net, right? So now we have this, we know like our we know the middle, right? The middle of linked list, right? So once we know this, the middle of the linked list, we can reverse it, right? We can reverse this second half of the linked list, right? So when we reverse it, so what do we do? How do we reverse it, right? So we need to have another pointer previous, right, to reverse it, right, to reverse the second half of the linked list. So as you can see, the next of this slow pointer, this slow is going to be previous, right? Previous was none inside, right? They say none, right? So where two is going to point to none, right? And when slow is at this position, previous is going to be here, right? And three is going to point to the previous, right? So our new linked list is going to be this one. Three is going to point to, two is going to point to none, right? So this is going to be our new the second half of the linked list, which is reversed, right? So once we reverse this linked list, since then the second half and the first half of the linked list have the same number of nodes, we can just let's say this the first half is going to be the four is going to be the first node, and two is going to be the second node, right? This first half of the linked list is going to be this one, and we will add the nodes in the same position, right? Let's say we can add three and four, right? It's going to be seven, and we will maximize the sum. And at this position, we can add two and two. Their sum is going to be four, but the maximum so far is going to be three, right? Because four is less than is going to be seven, and because four is less than seven, right? So so we are going to solve this problem, right? So let's go to the implementation. The time complex is going to be O of n, right? And the space complex is going to be O of one. So let's go to the implementation. So we need to have the slow was initially pointing the head, and the fast was also pointing to the head. So while fast and so fast dot next, the slow moves one step at a time, right? Slow is just slow dot next, and but fast moves two steps, right? Fast dot next and next, right? It moves two steps at a time, right? Then our previous is going to shine none, and then while slow, then prev is going to be, we need to make reverse, right? So let's first we don't want to use the next of the slow, then we just then previous, I mean slow dot next is going to be the next of the slow is going to be previous, right? Then previous is going to be the slow pointer, and then once we have done this, we can just say a slow is just the temporary, right? Temp. Then current, let's say current is the previous, and let's say the first part of the linked list head is, we start from the first, let's say the first is just to the first part of the linked list. So we can just say cur, or we can say while first, because they have the same links. I mean, yeah, we will traverse till, yeah, we have to make current, right? Because we didn't make for example, we didn't make this this node 2.2 net, right? So we have to um, we have to iterate till the current is net instead of the first. So what we're going to do in at this point is max to win sum, like, or we can say max to win sum is going to be zero, right? Then we have to maximize, right? The sum between is going to be max of with itself and car dot val plus first dot val, right? We have to maximize between this values. Then we have to car is pointing to car dot next, and first is going to be first dot next. Then return, which return, what we're going to return is the maximum twin sum, right? So let's see if this works for the test cases. So as you can see, pass for all of the test cases. So the time is going to be, so the time is going to be O of n, and space is going to be space is going to be extra space is going to be open, right? So let's submit it. So as you can see, passed for all of the test cases. If you like this video, please subscribe and share for people who you know, right? Thank you very much.